Good evening, everyone.
Good evening.
Good evening, sir.
Good evening. Okay, I hope you all have gone through the revision sessions for the week 5, week 6, week all weeks, week 1 to 8. So sorry, for 5 to 8.
Yes, sir.
Okay, so today we'll be discussing the previous quiz, the quiz that was in the previous term. We'll be discussing the questions from that quiz. Okay, quiz 2.
Sir, I have a doubt. Can I ask?
Yes, towards towards the end of the session, you can ask this. Okay.
Okay, sir. Thank you, sir.
We'll be taking that as well.
Sure.
Okay, how many participants? Say 2. Let's start with 8-5. We'll wait for a few more participants to join. Okay.
Sir.
Yes.
Sir, in that time, can I ask the question while you wait?
Okay. This question is from.
So I just have like a conceptual doubt. So the in some questions, for example, if you see mock test for quiz 2, so question 9.
Okay, so you have some doubts in mock regarding mock, right?
So, but there's one conceptual doubt. It's not really a question.
Okay.
So when do I like they asked how many ways it's wrong. So
Okay.
in some questions, we require to even see the number of ways you can answer those multiple choices. And sometimes you have to check the ways in which you answer the question as a whole. So I'm not getting what is the right bifurcation? Like, when do you choose what?
Can you please repeat your doubt? Like, I didn't get exactly what you're trying to say.
Okay, sir. So suppose there are 5 questions, and each question, suppose.
Just let me know the question. I'll just go through it.
Sure, sir. Mock test for quiz 2, so question 9.
Okay. Mock test 2.
Question 9, sir. Question 9 in the stats paper of a qualifier exam.
Okay, I don't have that.
You want me to share the screen, sir?
Just a moment.
Sure, sir.
Question number 9. In the statistics paper of qualifier exam, there are 5 multiple choice questions, each of 4 possible. Okay. Find the number of each question has 4 possible answer options. Okay. So this is just regular MCQs that we have.
Right.
5 choice questions. Find the number of ways student will not get the answer correct. So first you will see how many ways you have of answering 5 questions. These 5, right?
Yes, sir.
Each have 4 ways. Isn't that right?
So that's right. So I have one doubt, sir. So my doubt is here, sir. So that you see the question, it says, find the number of ways the students will not get all the answers correct.
Huh.
So we can. So the way I thought was that not all answers correct means he cannot have 5 right answers. He can have 4 right answers. So then I did cases like that, with 4 correct, 1 wrong, then 3 correct, 1 wrong, like that.
Okay, so no, but this is saying not all will not get all
yes,
the answers.
Sir. Yes, sir. So I didn't consider the one probability which says 5 correct and 0 wrong. I started with 4 correct and 1 wrong.
How many questions we have? 4. So basically, how many? If you have these 5, how many ways do you have of answering one question? 4 ways, right?
Sorry, sir. I didn't get your voice broke.
Okay, so I'm saying we have 5 multiple choice questions, right? Each question has 4 options.
Right,
okay?
Sir.
So for each question, we have 4 choices, 4 ways to answer the question, right?
Yes, sir. Correct.
So for 5 questions, it will be 5 raised
4 raised to 5.
5. Yes, exactly. So
right,
that
sir.
will be 1024.
Yes, sir. So that's exactly my question, sir. So why isn't my approach correct? Why, like, where am I wrong?
I'm getting to that point. So that is, you're clear with that. We will have 1024 ways of.
Clear, sir. Yes, I'm clear with that, sir.
So this question, like what you have done in this question, you have taken is it as this, like you can get 4 right, 1 wrong, 3 right, 2 wrong, 2 right, 3 wrong, right?
Right,
This
sir.
is how to approach it. But this is not what the question has asked. This is entirely not what the question has asked. The question has asked, find the number of ways a student will not get all the answers correct. It means all the answers have to be incorrect.
Okay, right, sir. So maybe
Huh.
I took it in the wrong way, right, sir? Okay.
You took it in the wrong way. So there is only one way in which all the answers will be correct, right? That will be the
Right, sir.
correct. So
Correct, sir.
1024 minus 1.
-1. Correct, sir.
Hmm.
Yes, sir.
1023.
Got it, sir.
Okay.
Thank you, sir.
So now just let me get this started. Is my screen visible?
Yes, sir.
Hello, sir.
Yes.
Sir, will the solution of mock test 2 will be uploaded? Mock quiz 2.
Yeah, a solution will also be uploaded, and you will be having a session tomorrow where mock 2 will be discussed thoroughly. Okay. Tomorrow is like today we have previous term quiz solving. Tomorrow will be mock solving.
Okay, thank you, sir.
So I encourage you all to just solve along with me. This is for the previous term. This was the paper statistics. Okay. Okay. This is the first question. I want you all to go through this first, then we'll discuss the solution as well. In the meanwhile, what you can do is you all can post your answers in the chat box. So we'll keep a track of all the answers. You have the solutions just before you, but I encourage you all to solve the question on your own and just relate the solution with whatever you get your answer. Okay, this is a pretty simple question. Anyone still trying to solve this question? Hello? Am I audible?
Yes, sir. Yes, sir.
Yes, sir.
Okay, let's get to this question now. So what it has said, the first question is rating feedback as poor, good, excellent of 5 customers is collected in the shop. So first of all, what type of scale do we use for this? Rating poor, good, excellent. What type of scale has been?
Ordinal.
Categoric.
Yeah, categoric is which one?
Ordinal.
Okay, ordinal. So everyone is clear that this is ordinal scale, right?
Yes, sir.
Yes.
Okay.
Yes, sir.
So in ordinal scale, this is the first part of this. If feedback of 2 or more customers are recorded, suppose we had the 5, it was like this: poor, good, poor, excellent. Suppose these were the 5 feedbacks that we got. Okay. New data set will always be bimodal. Is it necessary that it will be bimodal?
No, sir. It
Suppose
can be, but not necessary.
that is the thing. Suppose the new 2 observations that we added, let me write them in red. So suppose they both are this good. Is this data set bimodal?
Unimodal now.
Exactly, in unimodal. It can be bimodal. Suppose I added this E comma P, E comma P. Okay, it can be.
It's still
it has
unimodal, sir.
it has three more in GG.
Unimodal.
Okay. Sorry, it's unimodal. I didn't see this P. Suppose which one we added PP, G we added, and we added E. Now we have G 3 times and P 3 times. P, right?
Yes.
PP. It is bimodal. So it is not necessary that it will always be bimodal. It depends on what type of observations that are being added to the, what type of new observations we are recording for this particular question. Okay. So this is for the first part that rules out the first part. Now the second part, the new data set may change as unimodal. Okay. Suppose this this was a GG. Let me. This was our old data set. Okay, this was our old data set. How is it? This is bimodal, right?
Yes, sir.
Yeah.
Now, what I did is I added G. Now, is this unimodal?
Yes, sir.
Yeah.
Here we can see this, the language that has been used is may. This may or this might not, right? So
Yes,
this
sir.
option, that is why we.
Sir, can you explain briefly bimodal? What is bimodal?
Bimodal data is that has two modes, right? Mode means the observation that is occurring the most number of times. Okay.
Oh.
That is, this is I think from week 1 or 2 week.
Okay, sir, bimodal. Okay.
So that is there. Now coming to the third, median of the new data set will always remain the same. Is it so? Is
No,
it
sir.
necessary?
Median might shift.
Median might
It will
change.
change, sir. Sir, it will change.
Not necessarily. It might change, right? We
Yes,
cannot
sir.
be sure. So because of that, we are ruling out this. See, it in this question, what it is saying, it is asserting with certainty, right? It will always. There is this certainty. Okay, whatever happens, it will always. That is not the case. We saw that in the first question, right? The first
Yes, sir.
option. So in this case, the median may change. Okay. Any doubts in this question?
No, sir.
No, sir. All right.
So this
Sir,
was
if
the first.
number of observation is increased, then definitely it will change, sir. Median.
What is median?
Median is, sir, which come in the middle, sir, of
Okay.
all
N by 2.
observations.
Okay, this is what is my median in this?
G. Third
Okay.
observation.
G is the median. If I like
Yes, sir.
add 2 more G's, then what is my median?
Sir, then also it's G, sir.
Okay, it is G. So in this case, it did remain the same, right? So now
Oh,
let's look for a case in which it might not be so. Suppose we had 5 observations. P, G, E, E. What is my median in this?
G, sir.
So now if I add 2 more observations, can you see clearly this will change? Suppose I added 2 more E's in this case. So what
Sir,
is
then
my,
it will change. E.
it changed,
C.
right?
Okay, sir, I understood. Sir.
It changed.
It may
It's not,
change. It may
it-
change.
yeah, that's what I said, may. In this question, it is saying always will remain the same. So that is not the case, right? It may change or it may remain the same, depending on what type of observations we are adding. So with certainty, we cannot be sure whatever, like the question has asked in this, is it will always be bimodal. Always it's certain that, no, always it's going to be same. No, that is not so. It may be same, it may not be same. Similarly, in this question, it has said may. Okay, there is a possibility of it happening or not happening. So that is the case. That can happen like we just saw. Any other doubts in this question?
So, small doubt, not regarding the question, but just general. That when we are checking the median for ordinal data, it
Yeah.
should be in the order, but the direction of the order shouldn't matter, right? That if I were to
Hmm.
write E, P, G, G, P, PP,
Hmm.
that is also the same, right? As P, PP, G, 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 E.
Okay, can you see my screen? I have written something, PGE.
Yeah.
What is my median?
G.
G.
Okay. If I change it like this, EGP, my middle value is not changing, right? If
Yes.
I'm kind of flipping it, right?
Yes.
My middle value does not get affected by that. So because of that, yes, it is right that if we consider from this side or this side, my median will always be there. Whatever, if even if I write it as GGEPGGP, okay?
Yeah. Okay.
Any other doubts? So in quiz 2, what mostly will be asked, most questions will be from week 5 to 8, but there might be some questions, there will be some questions that will be asked from week 1 to 5 as well, 1 to 4.
Mhm.
Moving on to the next question. Okay. I encourage you all to solve this and just post your solution in this in chat box. Okay, somebody has said there is no session tomorrow. On the calendar, I think it has not been updated yet, but it will be updated in a while. Is everyone solving this question?
Doing so.
Okay.
I have one question. If these mock tests will be available till 2nd of April,
I think so. I don't know exactly up to which point they will be available, but I think so they will be available up to the quiz to date.
okay.
We have got only one person has responded with this solution. Okay, shall I discuss the solution now?
Yes, sir.
Trying to do so.
Sorry?
Trying to do the question.
Yeah.
So let's discuss the solution.
Am I audible?
Yes, sir.
Yes, sir.
Am I audible?
Yes, sir.
Yes, sir. You are audible.
Yes, sir.
Hello, can you all hear me?
Yes, sir. Yes, sir.
Okay, I was not able to see. Now, should we discuss the solution?
Yes, sir.
Okay. Just a moment. So what the question has said is that X contains observations of the bowling speed of a bowler. Okay, there will be X that will contain that are the observations of bowler, his bowling speed, and Y contains the observation of bowling speeds of another bowler. Okay, it is noted that each observation of Y is 1.5 times each observation of X. If the sample variance of X is 30, calculate the sample covariance between X and Y. Okay, first of all, what is our covariance of X comma Y? What is the formula for that?
So the summation of product of mean deviations of two variables.
X1 minus X bar into Y minus
Y minus Y bar divided by N minus 1.
N minus 1. Okay. This is our formula for covariance. Okay. Any doubts in this? You all remember this formula?
Yes, sir.
Yes.
Okay. Now, suppose this what was given us is that sample variance of X, if the sample variance of X is 30, we have been given sample variance of X, not sample variance. What is the formula for variance of X? What is this?
Yeah, that is
X minus X bar the whole square.
Okay.
Divided by.
If it's sample variance N minus 1, if it's population variance. Summation actually.
There is summation.
N minus 1.
This is this, right? Xn minus xi minus x bar square plus x2 minus xi bar square plus so on, right?
Yes,
so
sir.
this is sample variance for X, and it has been given to us. It is 30. Now let us suppose this is R. Let me denote this by R for the moment. Okay. So what is my variance for X? Variance of X will be xi minus x bar whole square plus x2 minus x bar whole square plus so on. I don't know the number of observations right now. Okay. So
Yes,
it will be 30 times R. This is what I have been given. So how do I go from this to this covariance? Just let me change the tabs from my just a moment. I don't have much space here. Let's take the question. It did not come here. Okay, we'll try to solve this here only. Now my covariance has been asked for Y. In Y, my each observation is 1.5 times the observation of X, right?
Yes, sir.
Yes, sir.
Did anyone solve this question?
Yeah, I got 45, but I was not confident, so I didn't write it.
No, no, that is the correct. Yeah.
New covariance will be 1.5 times of the old
1.5 times this old covariance. Okay, but let's approach it proper method wise. Okay, how we just multiplied it. New covariance is old covariance multiplied by this constant, whatever we got, 1.5 in this case. So the who solved this? I'm sorry, I didn't catch your name.
Sarita.
But
Sarita.
can you show me the question?
Yeah. So how did you approach this, Sarita? Hello.
Yeah, I was not sure about the formulae because I didn't go through the portions from 1 to 4, but I
Okay.
remember that each value will be, when it is 1.5 times, then the variance will be 1.5 times. I remember those things, so I kept that in mind and I did.
Okay, you did it from there.
I was not very sure, that's why I didn't write the answer in the chat.
We
Okay.
guess 30 into 1.5.
Sorry.
Actually, multiplication rule is the old
Yeah.
variance
Hmm.
into the constant, na?
Constant,
So
yeah, correct.
30
So-
into 1.5.
So 30 into 1.5, what will I get? The variance
45,
for
sir.
y.
Sir, I
45.
have a doubt, sir. I have
That
a
is
doubt.
that is variance
Yeah,
for
that
y.
is variance. Yeah, it's not
Huh.
covariance, so that is why I had a
Yeah.
confusion.
That yeah. Yes, Vansiswaran.
Sir, when we multiply with multiply the values with a constant, the new
Okay.
variance will be the old variance into the square of the constant.
Square of the variance. Exactly.
Yes.
So I was just
Yeah.
yeah. I was just seeing like how.
Sorry, I didn't get that. Yeah, okay.
Yeah, now I remember.
We wrote off.
New variance equals to old variance. Suppose you multiplied it by c, it is c square into old
Yeah.
variance.
Yeah, correct.
Because I have seen like many people when they that's why I said this, when many people see this 45, what they do is they just multiply old variance into what the constant is, right?
So
they
what I
see
did, but I knew the way I did it, it's not correct. That's why.
but yeah, you got the answer, but this was not the,
Yeah.
like you just calculated variance kind of
Yeah.
new variance, and that too was not correct.
Yeah.
Because our variance is c square times the old variance.
Correct.
Okay. Anyone has any ideas how to solve this question? Anyone solve this? We just have to do some manipulations around this, whatever I have written on the screen. I'm just taking all your doubts right now so that we will see, like Sarita, she just rectified where she went wrong, right? So let's
Sir, I do this same question, but it was like 2 multiplied some another observation, like it was 164 the sample variance, and 2 multiplied each observation, and it was 2 into that thing.
Okay, that I'm not saying like is it this, if is it multiplied by this, but what I am trying to show here is when people see this 145, because this option you will be provided in the exam as well, right? So many people tend to do this 30 into 1.5, and they see the first option to be 45 and they mark it. This will be right, yeah, this will be right in the first place, but the method you have done this, how you have approached this, the approach is not right. That's what I'm trying to show here. The approach is not right. What you are doing is you are just multiplying 30 into 1.5. Even if you are using this formula, new variance is equal to old variance into c square, then you have to take 1.5 square. You are just multiplying by 1.5. That is when we have standard deviation. Only then we multiply by this constant, right?
Sir, here it looks like the variance of y is also 30R. I mean, that is also 30R, right? Because we are changing all the values of y.
That like we will get variance, of course we will get whatever our variance is, but what I am trying to say is right now I have
I
not
got
just
a point, sir. Like the
Yes.
variance is xi minus x bar, sigma xi minus x bar whole square by n minus 1. And
Yeah,
when we
this one.
take the covariance, instead of xi minus x bar whole square, the second xi minus x bar is
yi minus
y
y bar.
minus y bar, which is 1.5 times. So that is why it came
that is how you like, if you
Yeah.
are this your in this question your yi will be 1.5 times x1,
Yeah.
right? That
Yeah.
is there, but what I am trying to say is, this is my point, what I'm trying to mention here, this is not how you approach this. New variance is equal to, like, because many people I think someone solved it just like 30 into 1.5. You got the answer correct, but even if this it is how this comes out to be, but I am trying to show this is not the correct method to approach this, right? You are
understood.
multiplying this. That is what I am trying to say here.
Yes, sir.
So let me see if there is some space. So we'll do this here. So what our question was, we had how many observations? Summation of xi minus x bar whole square over n minus 1. This was given to be 30. And what we were asked is summation of xi minus x bar into yi.
Sir?
Yeah.
So, if you write, please can you write sigma y minus y bar whole square upon n minus 1?
Why would I like?
I have a way to approach the answer.
No, this is just terminology. I am just, because see, this will be a lot confusing because one data set I am representing by x and its observations I am denoting by x. It's up to me how I denote it. You can denote it as p, q, r, whatever you want. So let's just go with the
No,
standard.
sir, I am doing the question solution. Like,
Okay, you want me to wait. Okay, you want me to wait for a while before discussing the solution.
no, sir, I thought you were waiting for
No,
someone.
I'm not waiting. I'm just trying to clear. Some people had done this 1.5 into 30 directly and got the answer 45, which surprisingly is correct, which is correct for this. But how it was approached, the method was not correct. Okay, that is what I had
Okay,
tried
sir.
to go up to this point. I have not solved the question right now.
Okay, sir.
So what this has been given to us, but now it has been given that
Sir, may I
each.
try? Sir.
Okay,
Sir, may
you
I
guys.
try?
Yeah, sure.
Sir, xi minus x bar. Okay. Into that's in I think and if I give relationship with y I minus y bar, I think the relation is like if I multiply y minus x minus x bar by
Sorry, your voice is breaking. Sorry, your voice is breaking. Sorry.
Hello.
Hello. Yeah.
Am
I audible?
Yes, sir, you are audible.
Okay, I think this whoever is trying to speak, you have some issue with your internet. Okay, now let's solve this question. We have spent a lot of time on this question. So this is what has been given to us, right? We have to somehow use this in this because this is the only thing that we have been provided in the question. Now, how would we approach this? We know that each observation, when we multiply, each observation is 1.5 times the observation of x. If x1 is 4, then y1 will be 1.5 times 4, right?
Yes, sir.
Yes, sir.
Similarly, if x bar is say 6, what will be y bar?
1.5 into y bar, x bar.
The x bar, right?
Yes.
So this is there is no doubt in this, right? So if I substitute, if I take this here, summation of xi minus x bar, what will be my each yi? It will be 1.5 times xi, right?
Yeah.
Yes, sir.
And what will be my y bar? It will be 1.5 times x bar.
Yes, sir.
This n minus 1, there will be no change. Okay, now I can see I am taking this 1.5 is coming out to be common throughout. So I will take this 1.5 outside. So I will be left with xi minus x bar into xi minus x bar over n minus 1. What is this? This is nothing, summation of xi minus x bar whole square divided by n minus 1 multiplied by 1.5. So from this equation, we know what is the value of this, right?
Yes.
So we'll just substitute 30 into 1.5, that is 45. It did come out to be like people, some people approached directly 30 into 1.5, but I just wanted to show you how it is 30 into 1.5. Okay, everyone is clear with this question?
Yes,
sir.
Yes, sir.
Okay.
Sir, what was the question actually? Can you
Okay,
show?
this is the question. Okay, now let's move ahead.
Okay, sir.
Sir, वैसे how many questions have you discussed till now?
This was the just second question.
Okay, sir.
This is the next question.
Sir, is this session will be available on YouTube?
Yeah, this is live streamed on YouTube as well. You can watch the recording later as well.
Okay.
The answer may be 4.
Answer may be 4. Okay. What you all can do is you can just type your responses in the chat box. 5, 4, 5, 5, 10 factorial into 2. What is the value of n? 4. Okay, there seems to be a tie between 4 and 5.
Sir, can we discuss the solution?
Okay, is everyone done?
Yes, sir.
Yes, sir.
Okay. First, it's someone who got their answer as 4. Can they unmute? Like, will someone volunteer to say how they got their answer as 4? Anyone? Okay. 5.
Sir,
Yeah. Okay. Yes.
sir, there is a round table and
Okay. Round table.
in the circular arrangement.
Okay. So we'll basically use circular permutations. Okay.
If we have to arrange n persons, then it will be n minus 1 factorial.
N minus 1 factorial. Okay.
And
from,
oh, sorry, sir. Yes, sir. Continue.
No. I'm just hearing what you're saying. Okay.
Then, sir, there are 12 ways. It means 12 ways. It means 3 factorial into 2. We can write it as.
Okay. This is what you're trying to say. We'll get this equation. No?
Yes, sir.
Okay. Is this correct?
Maybe.
No, sir.
No, sir. There will be 2 factorial as well.
2 factorial into n minus 1 factorial.
Sir, it will be n minus 2 factorial multiplied by 2 is equal to 12.
Who said this? N minus 2 factorial into 2 factorial.
Yes, sir.
Okay. This is the right approach.
Yes, sir.
N minus 2 factorial into 2 factorial. This is how we get our, this will be equal to 12. Now let's see how this will be. Okay. Let me just erase all this. Okay, so you all have watched this how ma'am has derived this formula for circular permutations, right? What she has done, suppose there were 4 objects, suppose there were n objects. What she did is she fixed one object, right? Then she made permutation of remaining objects. So she made permutation of n minus 1 objects, right?
Yes, sir.
So in this case, what it is saying, 2 people will be together. So how many people are we fixing? 2 people.
N minus 2 people and n minus 2 are left.
N minus 2 are left, and we have to arrange them, right?
Yes,
so
sir.
for them there it will be n minus 2 factorial. Okay, and these 2 people, their internal arrangement can be 2 factorial, right?
Yes, sir.
So multiplied by 2 factorial, what is that given to be? 12. So this will go to 6. We can clear.
Why n minus 2 came?
Okay, why n minus 2 came? Just discuss. When we have circular permutations, what we do is, suppose these are our 4. These are people. They are sitting around the table. 4 people. Okay. Now you want to see their arrangements. What you do is you fix this one person. Okay. You say, okay, you are there. Then what you do is you permutate these 3 people. You change them. Okay. That is how the formula for circular permutations has been derived in the lectures as well. Ma'am has also solved this. Like she has taken quite some time to solve this, explain this. Then in this case, how many people were we fixing? Only 1 person. And how many were we left? If we had n people, how many people were left for us to permutate? N minus 1, right? And what will be the permutation of these n minus 1 people? N minus 1 factorial. Now, what it is saying, suppose these are your 2 people now. Now you are fixing these 2 people. Now, what will this change to? N minus 2. N minus 2 people factorial people arrangements will be for the remaining n minus 2 people, right? Suppose we had 4 people. You are saying 2 people will be together. Then how many people are remaining that you have to permutate? 4 minus 2. So it will be their permutation. Now internally, what can happen is they can permutate in two factorial ways, right? So that has been given. Yeah.
There was also a formula that n minus 1 factorial upon 2. So what was that?
That was when clockwise and anti-clockwise are same. That is, for example, when we have beads. When you flip this will just be the same. In this case, it's not so. When people are there, it's not so. It's when some identical objects are there, beads are there, something like that is there. So that is entirely a different question. I think we might have such question ahead. We'll discuss it as well. Okay. But that is what it. That is when we have n minus 1 factorial over 2.
No,
is
but
when,
sir, here n minus 1 factorial by 2, that formula should be used, right? Because it has not been. This clockwise and anti-clockwise are same. It has not been specified.
So when it has not been specified, that's what we have been, like in all the sessions that we take, we've taken in the problem solving sessions as well. Unless it has not been mentioned, otherwise you go with the general case. Okay.
Okay.
In this question, it has not been mentioned.
Those are different. Okay. So n minus 1 factorial. Okay. Yeah. Okay.
So this is what we get. 2 factorial is basically 2. So this will cancel out to be 6. So this is 5 minus 3 factorial. N will be 5, right? 5 minus 2 factorial is equal to 6. This is 3 factorial is equal to 6. From here, we get our n is equal to 5, right?
Yes.
Yes, sir.
So is this question clear?
Yes, sir.
Okay. There was something in this question. What was done is there was some optional. There was one optional question for each such question.
So can you say how n becomes 5?
N becomes 5. Yeah, it's clear. Like what this is what we have. N minus 2 factorial is equal to, what is it? 6.
6.
Sorry?
6. Yeah.
Then, sir, we are in trial and error method. We are putting the value to n or n minus 2 factorial equal to n minus 2 into n minus 1.
We are solving. Basically, we are solving that only. But we know that 3 factorial is 6. That is what I know. So from there, my n will be 5. Okay. We are solving it. Else we are doing. We are solving this n minus 2.
I got.
So if somebody had made some mistake in this question. There was an optional question that was given with this. Can you see this? This question was there. Okay, this was just like we had those EMQs, right? This was only if somebody got this question wrong, then this question would have been checked. This question would be checked. If somebody got this wrong, then this question would be checked. Is the concept is clear or not? Okay.
Okay, sir.
So this is the question. What it was saying. Selection of person will occur simultaneously, right? It can occur simultaneously. There is no such rule. We cannot do it together. So this will be there. Okay. So when this is there, this option is eliminated. Will this be with replacement or will this be without replacement?
Without replacement, sir.
Sir, what was this question? Can you? So I was disconnected for.
Okay, this is the question.
Yeah, this question is discussed.
Okay, this I'm just saying this is the same question. We are solving how we did this. Those EMQ type. This is something that EMQ type. Okay, this is an optional question. This would be checked if you made some if your answer in this question was wrong.
Sir.
Yeah.
Sir, if our previous answer was correct and if
then
we
it wouldn't be checked. Even if you marked this when you had this correct, you would be awarded full marks, right?
Okay,
it has been given. This question is optional. We will check your answers to this question if you make a mistake in the previous one. If you don't, then it won't be checked.
So if this EMQ type of questions are going to come in quiz 2?
This is from quiz 2. This is previous quiz 2. This is not EMQ per se. This is just if you got this wrong, right? They want to check. This is optional, right? This question is optional.
Optional questions will be there for quiz 2.
I don't I don't know, but we will we want to discuss. This was from the previous term, so it was there.
Okay.
This is an optional question. They want basically what they want to check is were your approach of solving this question was correct. Then they might have awarded some marks based on that. Okay, even if you got this wrong, they might have awarded some marks based on this. So selection will occur simultaneously.
For every question there will be.
No. This was just for these questions. This question only, I think. This is just to check if the concepts are clear, like you approached it nicely, and it's optional. Right?
So if the above question is correct, sir, then there will
no. This question won't be marked. This is optional. See what will happen. Suppose you got your answer 4. What is the answer? 5. So you made a mistake. Then what they will do is they will check this.
Okay, so they will check that whether my concept is clear or not.
They might have awarded some marks based on if this question is correct. Okay, that is just like a bonus.
So it's better to be on the safer side. It's better to
attempt the bonus.
Answer the option. Okay.
Exactly. So this will be our events will occur simultaneously, right? When we are seating these people, we can do such simultaneously. There is no restriction that we want to do them simultaneously, right? This is there. When this is correct, this naturally rules out this one. Now, will this be with replacement or without replacement?
Persons will occur simultaneously
means simultaneously means you can choose 2 people simultaneously at the same time. You can choose the people. You can arrange them simultaneously at the same time. Suppose you throw a coin. Okay, what will you get? Either a coin. You throw a coin. What will you get? Either a head or a tail, right?
Yes, sir.
Can you get head and tail at the same time?
No, they are disjoint.
What we call is that head and tail cannot occur simultaneously. That is how we say this. That is the definition of that as well.
Then where this occurrence is there in this question?
I'm just trying to explain what simultaneous means. What simultaneously means. I can do this if I suppose these were my chairs. Okay. At the same time, I can tell one person, you sit here, and you sit here, right? Simultaneously, they can be seated, right? It's not the case. First, I will have to seat, only then I can seat him, and only after that I can seat this person. No, I can tell them, okay, you 3 sit on any 3 chairs. They will sit there simultaneously, right? So that is what it means.
Sir?
Yeah.
Sir, if we if we don't know the selection of the person will occur simultaneously, and if we just don't tick this option, rather than we just tick the last three without replacement, order matters and permutation is used, will there be then also be a award?
Yeah, this is
over-
multiple select question. If you select, suppose you had 4 correct answers for this, you selected only 3. So you would be awarded for 3. But in these 3, even if you selected one wrong option, you would be awarded 0.
Yes, sir.
Okay, that is there. So of course, this will be without replacement. We cannot seat one person here, then take him back, then tell him, okay, sit here again. This will be without replacement, right?
Sir, this will be rude.
Yeah, this will be rude, and this will be very like illogical to say
Yes,
sit
sir.
there, then tell him get up and sit again. That will be very illogical to do. Now order will matter, right? That is what we saw here, n minus 2 factorial and this 2 factorial. That is why this 2 factorial came into picture, right?
Yes,
When
sir.
this is arrangement, right? The question has said explicitly arrangement. When it is arrangement, we know it will be our permutation. So order matters and order does not matter. It is knocked out. So permutation is used. Any doubts to this?
No, sir.
So this is the next question.
Sir, for
Yeah.
selection of simultaneous events.
Can you be a little loud, Tanmay?
Sir, selection for simultaneous event. Sir, like if sir, can you just explain? Sir, like I know it will be simultaneous, but once like simultaneous and not simultaneous difference, just for clarity.
Okay, simultaneous, like I just explained, non-simultaneous would be, suppose I am walking down a road, okay? This is my road. And there is this is like this. The road is like this. I can either turn right or I can turn left, right? I cannot, at the same time, I cannot go left and right. Isn't it? At the same time,
yes, sir.
So this is, I will say these two are not simultaneous because they will not occur together. They cannot occur together. They can never occur together, right? For this toss of a coin, head and tail can never occur together, right? I will either get a head or a tail. They will never occur together. So I will say these are not simultaneous. But if I am seating 3 people here, it's not the case that I cannot seat I cannot seat them together at the same time, right? I can seat them simultaneously. 3 people are okay. I'll tell them, okay, you 3 occupy 3. There are 3 chairs. Go and occupy those 3 chairs, and they can occupy it at the same time, right? It's not the case that if one occupies this chair, 2 cannot occupy this. No, it is available for him to occupy or 3 to occupy, right? So it will be simultaneous in that sense.
Okay, sir.
Okay, now this is the next question. Huh? Take your time to solve this one.
Sir, can you scroll down, sir? Can't see.
Okay, then it will be just the solution is there. I don't want to spoil this for everyone right now. You just post your answer in the chat box.
Sir, done.
Yeah. Okay, is everyone done with this?
Yes,
You
sir.
just-
No, sir, this time.
Okay, yeah.
Sir, 1 minute more.
Or take 3 minutes more. No pressure. It's all this.
Sir, I think we can discuss now.
Okay, is everyone done?
Yes, sir.
Yes, sir. Yes, sir, done.
Okay. Before getting to the solution, okay. Let me just check the responses. (15 over 36, 15 over 36, 15 over 36, 12 over 36, 15 over. Okay. So, can someone who got their answer as 15 over 36 explain how they got it?
Can I explain, sir?
Yes, sir.
Yes, definitely.
Yeah, so the event A is given as the second die is greater than the outcome of the first die. So event A will be 1, 2, 3, 4, 5. 1, 2, 1, 3, 1, 4, 1, 5, 1, 6.
Okay, just slow down a bit. I'll write this with you. This will be a then it will be
Yeah. 2, 3,
2
2,
4
4,
2 5 2 6 3 4 3 5 3 6 4 5 4 6 5 6
4 5 and 4
4
6
6
5 6.
5
This
6.
is my event A.
Yes,
Any
sir.
doubts? No. So what is my event B?
That will be 1 1 1 3 1 5 3 1
नहीं sir
3 3
1 1
3
1
5
3
1 3 1
1
5
5 3 1
3
3
1 3
3
3
3
3 5
5 ऐसे sir 5
5
1
1
5
5
3 5
3.
5.
This will be my event B.
Yes, sir.
Because B is that outcomes on the both the die are odd. So will there any 1 1 1 for 1? It will be only 1 3 and 5. The first die we'll consider. For the second die it will be 1 3 5 1 3 5 1 3 5. Only these cases will be our this event B. Okay, now.
So I have done the sum of them to be odd. So
Okay. What was your answer? There was someone who got their 15 by 36. They were discussing. Yeah. How?
Yeah,
What did you do
now-
next?
Yeah, now we have to omit the common elements from A and B, and we have to count them all. That will come to 15 by, and that will come to 21 by 36. And we
Okay.
have to
What
take
are
the
the
complement of it,
common
1
elements?
minus-
What are the common elements?
That will be 1 3 1 5 and 3 5.
Okay. Okay. 1 3 1 5 and 3 5. These will be our common elements.
Yeah.
So what? Now you are saying we will go for A union B, right?
Yeah. Yes, sir.
How many
That
elements
will-
are in? 1 2
21 by 36. Sir.
The
10
16
15.
15.
15 elements.
15 plus 6.
16.
No, sir. Just
16 elements,
Sir,
sir.
20 elements are in
Sir,
total.
21 are there, sir.
Our
Sir.
okay.
21.
Now
21.
let's
Yeah.
first clear this doubt. Are there 20 or 21?
Sir,
Those
that is
who
21, sir.
those who say
Sir,
21.
21 ही है सर गलती से कैलकुलेशन मिस्टेक होगी देखा नहीं था
Okay, where did we make this mistake?
Sir, in this 1 1 sir I counted it 4.
1 1. Okay, this will be 1 1 1 3 and 1 5, right?
No sir,
3
I am
1.
saying
Yes,
the
yes,
rest which you write it previously I saw them as 4 which was 5 left.
Yeah, these basically this will go for A union B. This will go and this will go, right?
Yes sir.
So this is our 15. These are 15 and these are 3 6. So we have 21 elements, right?
Yes sir.
Correct, sir.
Plus
So
mistake.
So
20
what we did is our probability of A union B. What will be our probability of A union B? 21 over
21 by
36.
36. Yes, sir.
So what will be probability of A union B complement?
1 minus 21 upon 36.
21 upon 36. So that will be 15 over 36. That is the solution for this question. Any doubt?
No, sir.
Okay. Okay, now to the next question. Okay, what I want you to do is in this question, I want you all to check the independency of check E1, E2 independency, check independency of E1, E3, and E2, E3. Okay, check this one out. This is the question. So I will not display the solution right now because then you'll all just know the solution and nobody will make mistakes and then we won't be able to rectify those.
Sir, even E2 and E3 are successive event, means one after another.
No. These are just events. They have been defined like that. You just have to check, are these independent? Check the independency. Check if they are independent. Okay.
There is no sign of dependency, sir. They are independent.
No, you have to check it.
So E1 and E2 are dependent, I guess.
Okay. Just post your answers in this chat box.
Okay.
Can anyone just mention what was the independency for 3 events, not 2 events? How would, if we have been given 3 events, how would we check if they're independent or not?
So like we.
Sir, if occurrence of one event is affecting the another or not.
No, I'm just saying, like, we had, what is the formula wise I'm saying, if E1 and E2 are probability of E1 intersection E2, if it is equal to probability of E1 into
0.105.
Okay, this is basically for independent events. We have this, right?
Sir?
Sorry?
Sir?
Yeah, I'm saying for independent events, this is how we check independent events.
Sir, I just want to ask one thing.
Okay.
Sir, if these two have probability like 0.015 and if we just multiply them and it goes like 0.015625, then both will be same or
So what will you get if you are saying I get the probability 0.1
0.015 0.015
okay, and
0.015625 are they same?
Well, it depends. You might have got this from some fraction a by b, right?
Yes,
and
sir.
you have also got this from some fraction a by b.
Yes,
a by v1. If they are same, they will be same. Depends on how you have got this 0.15. Okay, if they are same, what basically you have got it from there. If you have 2 by 3, 2 by 6, it is equal to 1 by 3.
Yes,
right?
sir. Yes, sir.
So it depends on, check for it. Instead of going for these decimals, I suggest you to check in fractions, because there it will be much easier to see if they are equal or not, right?
Okay, sir.
Okay, I was just asking, what is the independency of, this is the independency of two events.
Yes, sir.
There was a condition, sir, 4 conditions, whether event 1 and 2 are independent, 2 and 3 are independent, 1 and 3 are independent, and all 3 are independent.
Okay, so this was for what you're saying is, if we have probability of E1 intersection E2 intersection E3, if this is equal to probability of E1
into probability of E2 into probability of E3
of E3. This is not sufficient for
and
right?
and probability of E1 into probability of E2 and probability of E2 into probability of E3 and probability of E1 into
We'll
E3.
make a pair of two.
Yeah.
That is it. So this is what I wanted to say. If any one of these pairs fail to be independent, then this will fail to be independent, right?
Yes, sir.
Because this is a must condition. If 3 events are independent, first this should be followed, then these 3 should be followed. Okay. So if any one of these 3 fail, it means they are not independent, isn't it?
Yes, sir.
Okay. So is everyone done with this question?
Sir, I am not getting any idea.
Okay, this is simple independence. You have to check simple independence of these events. Okay, we'll just solve this as well. Okay, now we have got a lot of solutions. Pradeep Kumar, Saritha, E1, E3 independent, Radha dependent, E1, E2. Okay, this was the question now. E1 and E2 are independent, E2 and E3 are independent. These were the solutions. Now let's see who got. E1, E3 independent, no. E1, E2 dependent, no. E1, E3 independent, no. E2, E3 independent, no. Did anyone get this solution?
Sir, I got 2 to be correct, actually, but one thing, that E2 and E3 independent, how, sir? I don't know.
Is dependent. Is dependent, not
They are
independent.
dependent. They are not independent. They are dependent.
No, in the option E2 and E3, the second option, sir.
Okay.
Yeah, it says independent, right? How they are independent?
We'll check that. We'll check that. But I am saying, did anyone get these 3? Anyone
Yes,
got
sir,
these?
I just got 2.
Who got this?
I got opposite.
Sir, I got 3.
Sir.
Okay. So I would encourage someone who got all 3 correct to solve this along with me. Okay. So can someone volunteer to do so? Somebody was just saying right now, saying they got it all the 3 correct.
Yes, sir, I got 3, sir.
Okay. Okay. So what is our event first? Number on the card is greater than 150, but less than or equal to 200. So it will be 151 all the way to 200, right?
Yes, sir. It
How
will be
many
50 upon 50, sir.
Sorry?
50, 50, 50.
It will be, we will have 50 elements, right?
Yes.
In E2, what is number of the card is greater than 106. So it will be 107 to all
In
the
all
way
event,
to
it is 50, sir.
106 is also included.
Greater than or equal to 106. Okay, it's 106.
Yes, sir. So it is all in, sir. In all event, it is 50, sir.
Okay, but less than 156. So it will stop at 155, right?
Yes, sir. Then also it is 50, sir. Because
Okay,
we included 106.
We included 106. So what is my probability of E1? Probability of E1 is
50 upon 500.
1 upon 10.
Sorry? Yeah.
Sir, if
0.1.
we just minus E2, it is coming like 49 elements.
Sorry?
Yes, sir. If you just minus 155, 106 from 155, it is getting like 49 elements.
We are
No,
these are 50 elements.
Then we add +1 to it when we include both the numbers.
Where both the numbers are included now.
No, sir, but less than it is written like.
It is less greater than or equal to 106, but less than 156, right?
Yes, sir.
So you are saying these are 49 elements.
Yes, sir.
Okay, let's do one thing. This one for E2 you are saying. So it's
Yes,
starting
sir.
from 106 to 155. Okay. 106, 107. Let's count them one by one.
Sir,
108. No, this is 50. These will be 50 elements.
Sir, 50. Sir, you are saying like these are just a piece of cake.
Sorry?
सर आप तो ऐसे बोल रहे हो सर ऐसे एकदम से काउंट कर दोगे सर बहुत ज्यादा हो जाएंगे ठीक है सर 50 है
Is everyone getting this 50 right?
Yes, sir.
Yes, sir.
Okay. These are 50. Okay.
So E3 is
what
also
will be our
50.
probability? But first, let's see the probability of each individual event. Okay.
50 upon 500.
50 upon
500.
What is
Because there are 500 cards.
There are only
Are you sure
400
there are
cards.
500?
There are 400 cards.
So 401.
Sir, 401, sir.
401, sir.
Then 100 to 500.
From
Okay.
100 to 500, right? That's 401.
Okay. Whatever. 400 or 401. We'll do this counting again. 100, 101. Let's do that. Okay. See, for this moment, suppose this is our A. Total cards are A. For E2, I don't want to get into this debate right now. These are 400 or 401. What will be our probability of E2? This will be also
50
equal
by
to 50 by
A.
50 by A. So what is my E1 intersection E2? What is my E1 intersection E2? Anyone?
sir 5 elements
5 by
Which
150 151 152 153 154 155
155, right? So I have these 100, 150 to 155. These 5 elements are my common. So what is the probability for that? 5 over
sir 5
A,
upon yes sir
right? So what is the probability of A intersection B? This is 5 upon A. What is my probability of E1?
sir 50 upon
50
A.
upon A.
And what is my probability of this E2? 50
50
upon.
upon A.
50 upon A.
So when I solve this, what is my A coming out to be? Anyone?
401.
400.
Sir, it is saying like 100 to 500, so it will be 400 cards.
It is starting from 100.
That is why I didn't want to go into this.
401.
That is why I didn't want to go into this debate. That's why I had kept it as A. There will be how many cards will this be?
401 will be there, right?
401.
Why won't they be 400? If anyone
Can you
would
show
like,
once again question?
this is there. Cards numbered 100 to 500.
It is only
100.
400.
So it starts from 100.
So
Okay, it starts from
One
100.
card is drawn.
No, I'm not saying. I'm coming to your doubt. Are they 400 or 500 cards?
Sir, 400.
401, sir. 401.
401.
It is 401. So we start from 100, then it is 401. If we start from 101, then it will be 400, right?
400, okay.
If we start from 101, then it will be 400 cards.
Then
here it is 100
starting
to
from
500,
100,
right?
This is 100, right. So is that clear why this is 401?
No, sir.
yes, sir.
Acha, 400,
Is it-
yes, sir. 400. Okay.
No, 401.
401.
401.
Your voice was not audible, sir. Everyone is speaking in between. So can you explain?
Am I audible now?
Yes, sir. So please mute all, sir.
No, this is basically an interactive session, so I want this to be a little interactive, so I will get where mistakes are being made. That's why I want to see this. Okay.
Sir, please explain one more time, sir, why it is 401.
Why is this?
401. Why it is 400?
I'm not saying it's 400. I'm not saying 400.
Sir, take example of 11 to 20, then all will.
500 minus 400 plus 1.
Plus 1. 500 minus 100.
Because we are including 100 also.
Sir, for ease of understanding, we can subtract 99 from both of the sides, like from 100 and from 500. So the counting becomes from 1 to 400.
How many elements are there?
11.
11.
Now, does this make? Can you relate this?
Yes, sir. That's why I'm saying it's 401.
Yes.
In subtraction, we usually don't count the smaller element, but here we add the fourth element, the first and last one. That's why we add +1 to it.
We add +1. That is.
Whenever we start counting, we start from 1.
1. Exactly. That is here. If that is what it is here. If it would have been like this, then it would have been 400.
Yeah. If we are counting 1 from 1 to 100, then it will be 100. And if you are counting 0 to 100, then it will be 100 to 101.
So is the doubt clear why this is 401?
Yes.
Okay,
Yes,
that is let's discuss that for that is there. How it is 401, you can relate to this. This is suppose this is 100. This will be 100 will be something like that. We are not starting from 101. Because of that, it will be our 401. Because if you are stopping at 10, then you would say relating to this same logic. If I am starting from this 101 to 500, I am starting from 0 to 10. Then according to this logic, I should have only 10 elements, right?
Yes, sir.
But how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Applying the same logic here as well, I will have how many cards? 401.
Okay, sir.
Right?
Clear, sir.
Okay. Now, what is the, where were we? I forgot where we were.
Sir, A is equals to 400.
Just
401.
401, sorry. Sorry, bro. Sorry.
It's okay. No, it's okay. So what is our probability of E1 intersection E2? What is our, for that matter, what is our E1 intersection E2? What is
5 upon 401?
5 upon 401. So what is our probability of E1 into E2?
Sir, 2500 upon में 401 का square.
Divided by what was this? Did somebody calculate this, or what it is coming out to be?
Sir, something like 1600, 160000 something.
Yeah, you are wrong.
Just a moment. So what is our basically this independence? How do we check independence? Probability of A1 into A intersection B is equal to probability of A into probability of B. What is our A intersection B? E1 intersection E2 in this case? Huh?
5 upon 401. 5 by
Okay.
401.
5 by 401. What is our probability of A1? E1.
50 upon
5 upon 401.
50
upon 401.
50 upon 401.
Okay, what is this and what is the other?
160081.
401. Okay. Can we see are these two independent or not?
No,
Sir,
sir.
it is independent, sir, for 2 decimal places, not for 3 decimal places.
Okay, we're not checking that, but if are they independent?
Yes, sir.
No.
Yes.
Yes, they are. When you saw, yeah.
For LHS, it is showing 0.012, and for RHS, it is showing 0.015.
0.012,
and in RHS, it is showing 0.015.
0.012524. This is what you're saying?
15. Yes, sir.
So this is similar, like this is almost the same. If you take up to 3 decimal places, it is same, right? Since this we have this huge number we have, because of that it is a little bit different. But these two are same, right? If you are taking up to 2 decimal point accuracy, 3 decimal points, right?
Yes, sir.
So from there, what we are getting, our probability of E1 intersection E2 is equal to probability of E1 into probability of E2, isn't it?
Yes, sir.
So what is our E1 and E2? Anyone?
E1 intersection E2.
So what E1 and E2 are independent, right?
Yes, sir.
Now what is our E3? What is our E3? Just a moment.
50 upon 401.
Yes, sir.
Yes, sir. 50 upon 401. That is also 50 upon.
What is our E2? E2 is.
But sir, what you calculated, they are not equal.
They're not equal, but we just saw they are equal.
Sir, 5 upon, if you multiply 5 upon 401, multiply both in numerator and denominator by 401. And sir, on left hand side, you multiply 401 on both numerator and denominator. And
sorry,
just to check whether the LHS is equal to RHS or not. So we can multiply 401 on both numerator and denominator on
both sides.
Left hand side.
Okay. Just a moment.
So will this session be uploaded to YouTube?
Yeah, this will be uploaded to YouTube.
Okay.
Just a moment.
Yes, sir. They are not equal.
Yes, sir.
E1 and 2.
If you take cross multiply, then it will not come out to be.
Yes, then we will get 401 multiplied by 5 is equal to.
Where are we making the mistake? I'm just seeing where are we making mistake somewhere. Are we making mistake somewhere? Even the number on the card is greater than 150, but less than or equal to 200.
I think we have done mistake in intersection part, sir. Even intersection E2. Is it really 5?
I think so too. What is our E1? Greater than 150, but less than.
Sir, equal to both sides, 150 to 200.
Just a moment. Where we have done this mistake, I want to see.
It is 5 only intersection.
Sorry?
It's 5 only, sir.
Intersection is 5 only.
5.
151, 52, 53, 55. Yeah.
55. So E1 intersection E2. What is this? One greater than, it is 151, 152, 153, 154, 155, and 156.
No, sir,
right?
156 less than, sir.
Okay, it's less than 156. So 155
it's
there. So what is our
5 upon 401?
Just a moment.
0.0124, sir.
0. Just calculate this. This will be what will be our probability of E1 intersection E2. It will be
0.0124.
5 upon
401.
401. Okay. So what will be my probability of E1? The number on the card is greater than 50, but less than or equal to 200. This will be my 50.
50 upon 401.
50 upon 401. And what is my probability that a number on the card is greater than or equal to 16, but less than 156? This will be again 50 upon
401.
Okay, if you multiply 01 on this both sides.
It's not coming equal.
Sir?
Yeah.
I think
Sir,
E2 is 49 by.
Yes, sir. Yes, I want to say that.
Which one is our 49?
E2.
E2?
No,
No, it's 50.
Yes, sir. It's 50. Not 40.
Mm-hmm. This is 50. This is my 50, right? I have 50 events for this. 150 greater than 150, 151 to 200, 200 minus. Is this 50 or is this, how much is this?
E2 will be 50
50,
only.
sir.
E2 will be 50 only.
Sir,
E2
everything
is
is right, sir. We are getting the answer. I have rechecked.
All three are 50.
Yes, sir.
Sir,
all.
who is saying it's wrong, sir? Who is saying this is wrong? I have rechecked
What
this.
is
It
that?
is right.
Just a moment. Our probability of E1 intersection E2 is 50 over 5 over 401, right?
Yes, sir.
Who was saying this? Like, I'm not able to see where like what we are confused at. This is what you got, right? J.
Yes, sir. Yes, sir.
So what is our probability? 50 into 50 over 401. Are they coming out to be equal? 401 into 401.
It's coming as 0.0155.
Yes, sir.
Yes, sir.
And 5 upon 401 is coming as 0.01246.
This is coming to be 0.
There is a significant difference, sir.
One is 0.012, another is 0.05.
You are not audible.
You're not audible. Sorry, you're not audible. Sorry?
Am I audible, sir?
Yeah, you are audible.
Yeah, then 5 by 401 is 0.01246. And the other side is 0.0155.
0155. Is it coming to be?
Sir?
Yeah.
Sir, when I'm doing like 400 card, it is left side, it is 0.015 and right side, it is 0.015625.
15625.
When
Just
doing cards 400.
when you are dealing with 400 cards, right?
Yes, sir. They are coming to be similar.
This wrong. I am not able to see this where we are going wrong with this. Or are we going wrong with this one or not? 100 to
Why is she
500.
taking 400 cards? Why is she taking 400
Sir,
cards?
who was the one who was the one just calculated this way?
J, I think.
Sir, he can then he can tell us now how to calculate it.
Yeah, that's what. How did? Sorry, how you got this E1 and E2 are independent, right?
So you only told us that for big numbers, it doesn't matter that.
No.
It is
Yeah,
true
but
that
yeah. They are saying that this is 0.125 and that is 0.155. These are two separate numbers, right?
Yes, sir.
So how did you get the same?
No, sir. I am also getting this, sir. But you told us that.
Okay, I thought. Okay, when you said that, I thought you are getting 0.12. When you said that, I thought you were saying I got 0.124 at 0.0125. That is what I thought you are getting.
Sir, he was comparing 5 by 401 and 50 by 401.
Okay,
he did not multiply. Yeah.
Okay. That's what I didn't hear your question properly. Sorry for that. E1 and E2 are E1, E2, just a moment.
Let's move forward, sir.
Let's keep this question for a while. I'll just come to this question. Let's come to the next question for a while. Sorry for this. I'll just solve this as well. Okay, let me see how many questions are left there. Okay, do this question in the meanwhile.
Sir, again numbered one.
No, this is that. This is pretty easy.
Sir, may I take my leave? I'll follow this in the YouTube tomorrow.
Definitely.
Thank you, sir. Thank you, sir.
I think we will use base theorem in this.
Okay, what is this? Okay, just like type your answer in this chat box. We'll see what we're going to use. Okay.
Done, sir.
Okay, everyone is done with this?
Yes, sir.
Okay, now let's discuss the solution. Okay, what we have given is a box contains 15 numbered balls. So we have a total of 15 balls. Okay. And such that the red color balls are numbered 1 to 8 and the black number. So this is suppose these are our red balls and just draw them here, denote them
Sir,
in red.
8 red, 7 black.
Yeah, these be our numbered 8. This will be our red balls. 8 red balls and the remaining will be
7.
black.
Yes, sir.
Okay. So what is the first? We'll see. If we select a ball, what is the probability of the ball being a red? Let me
Sir,
just.
here we don't need a tree diagram. It is.
I'm just explaining.
Okay, sir.
Hello. Sir, your voice is not audible.
Sir, I think you're mute. Sir, are you speaking?
This is our red and black. What the question is then?
Sir.
Where is sir?
He is on mute.
I think source connection is low.
Sir, you are
Where
audible. Your screen.
where
Just a
has he
moment. Just a
gone?
moment. Just a moment.
Is he in the meeting?
He said just a minute.
Okay.
I'm sorry, there was some trouble with the internet. Just a moment. Okay. What we have been given is now if a randomly ball chosen is even numbered. Okay. What is the probability that the ball is selected of red color? We know that the randomly chosen ball is even numbered. Okay. How many even numbered balls we will have? What will be our even numbers
4
ball?
in red and 3 in black. Total 7. Sir?
14. So am I audible?
Yes, sir.
Am I audible? Okay. So how many even number balls I have in total? I have 7 even numbered balls. Even numbered. Now I have been given these, like I have got a even numbered ball. So total these will be my 7, right? And of
Yes,
these,
sir.
I have been asked how many are. What is the probability that it is of red? How many balls of red color
4.
are even numbered?
4C1.
4. Yeah. So what will be our 4 divided by 7? That this is the
0.57.
okay. That is the solution. This is except in this range. Any doubts in this?
No, sir.
No,
Okay.
sir.
To the next question, This is the next question.
Excuse me, sir.
Yeah.
Sir, in previous question, my doubt is why can't it be 4 by 15?
Because we have been given that we are getting these even numbered balls. This is given now. We have only this is given. If a randomly chosen ball is even numbered, so we will be only considered with
Only
these
we are
even
taking.
numbered balls.
Okay. 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 Okay, sir. Thank you.
Am I audible?
Yes, sir.
No.
Yes,
Okay.
sir.
Okay. But I might have lost my internet. Okay.
Sir, done, sir.
Let's wait for others to solve this as well.
Sir,
Yeah.
sir, can you tell me the answer of the previous question?
0.57.
0.57. I think, sir, I solved it using Bayes theorem, though you did it very easily.
Huh.
But Bayes theorem is applicable, right? Because I
you
have
can, yeah.
0.56. I have answer, right?
Okay, yeah.
Yes, sir, I have
Bayes
also got.
yeah,
by
yeah,
Bayes
you
theorem.
can. Yeah, definitely. You can approach it using Bayes theorem. But in this question, since it was like there were small given numbers, it was much easier to just restrict my sample space to those 7 even balls, right?
Yes, sir.
That you definitely you can use Bayes theorem in this question as well.
Yes, sir.
But it is easier to solve it. Like sometimes we don't need Bayes theorem, right? We have seen
Yes,
that
sir.
even contingency. It
Yes,
was
sir.
easier
Yes.
that way. Okay.
Yes.
Sir, done, sir.
Okay, everyone is done with this?
Yes, sir.
Okay. Now, what we have been given, a basketball coach wants to draft a team. For drafting a team, 5 players are available for the position of point guard. So 5 players for point guard. Let us denote this by PG, point guard. Okay. Position of shooting guard is G. How many players we have? 4. Okay. 6 players are available for the position of small forward. Okay. And then 2 players are of position of power forward. How many are there? 2. And 3 players for the position of center. 3. If he needs to select one player for each of these positions, then how many ways can he draft? So can anyone tell what this will be?
So 720 total. 720
20,
ways.
of course. Yeah, 720. But how will
First
it be
one in
selected?
5 ways. The second one is 4 ways.
Yeah.
And the third one is 6 ways. And the fourth
and
one is 2 ways. And the fifth one is 3 ways.
from
And we
this,
multiply it all the numbers.
this is
right?
6 factorial, if you can see.
Yes.
6
I
into
think.
5 into 4 into 3 into 2, and it's 720, and that should be the answer, hopefully. Yeah, that is the
Yes.
answer. Any doubts in this question, anyone?
सर कुछ क्वेश्चन इजी दे रखे हैं वैसे इसमें.
If every like some questions you might have studied the concept well, that's why they seem easy.
Okay.
Okay, now let's move ahead. Okay, this was for this question only. What will in this question the selection of players will be simultaneously? We can select the players simultaneously, right?
Yes, sir.
Yes.
Okay, this rules out this option. With replacement, will it be with replacement or without replacement? It will be without
Sir,
replacement. You cannot
yes,
select
sir.
one player, then tell him you are not selected, then select him again. That doesn't make sense. So order does not matter in this, right? Because we are just selecting one player
Yes,
from
sir.
each of these combinations. When order does not matter, we know this is
Combination is
combination.
used.
Yes. Okay. This
So can
this
you
is the
show
next.
that question one more time, sir? Just one
Yes,
more time, sir.
Yeah.
Sir, can you give example of a replacement with replacement? One example.
Okay, sir,
Okay.
done. Sir, I was
Replace.
thinking. Yes, sir, done.
Yeah.
Thank you.
Okay. With replacement, I will give you an example. Suppose, when repetition is allowed, basically whenever like you saw how many arrangements of this word R, A, I, N will be there. If repetition is allowed, there it will be with replacement. Because if I am using R here, I can use R here again, right? If repetition is allowed, isn't so? So I can replace it again. So in such case, repetition is allowed, and then we can say, yeah, it will be so. Though the next question is, this is, can you see this? On the bottom, it's here.
Done, sir.
Everyone is done this?
Yes,
Yes,
sir.
sir.
Still solving? Okay. Now what we have been given is we have to arrange the words of this letter remain, and the letter of this word remain, R-E-M-A-I-N, okay, in such a way that the vowels either occur only at odd places or even places. So if how many letters do I have? 1, 2, 3, 4, 5,
Sir,
6.
3 even
4, 5, 6.
places,
Suppose
3
this is
odd
index 1, index 2, index 3, 4, 5, 6. Now my what can happen is my vowels can either come here. Vowels it's talking about, vowel 1 will be here. I have 3 vowels, E, A, I, right? Or vowel
Yes, sir.
2 will be here, or vowel 3 will be here, and then I will have arrangements of these 3. So basically my vowel can be at either these 3 positions, or what can be the cases, it will be at these 3 positions. Okay,
Yes, sir.
so let's first see what the solution everyone has got. 72,
That is 72, right?
Yeah, it will be 36 for one case and 36 for the other case, right?
For another
Yes,
case.
sir.
Yes, sir.
So how will this be? Now, who got this solution correct?
Me
I
also.
got
Everyone.
Sir, here is 2 cases. For
Mhm.
first cases, it is 36 ways, and the second cases, it is 36 ways. Right?
That's what I said. It is 36 ways. How do we get these 36 ways?
Okay, when in first cases, when vowels are only at odd places, here we can arrange vowel in 3 factorial way, and we can
Okay.
arrange consonant in 3 factorial way, right?
Okay,
So that gives us 36. Again,
Okay,
in case two, when vowels are only at even places, here again, among even places, we can arrange vowels at 3 factorial ways, and we can
then
arrange
consonants
consonant in
at
3 factorial ways. Yes, and
exactly.
that is also 36.
6
And it
into
is
6
odd,
plus.
and it is odd. So plus we have to add them, right?
Yes, sir. If
So
or is given,
basically
we will add.
it is there, right? This is what we will get. 3 factorial
Yes, sir.
into 3 factorial plus 3
Plus
factorial into 3 factorial.
3 factorial,
right?
correct? Yes, sir.
So this is coming out to be 36 plus 36, that is 72. I don't think there are any doubts in this question, or does anyone have a doubt in this question?
No, sir.
Any
Yes,
doubts?
sir. No, sir.
Okay, this was there. For the same question, it was we can select these simultaneously, right? If we have
Sir,
to place
permutation.
without replacement, we cannot take one vowel and then replace it again and again. And since it is arrangement, it will be our order matters, and order matters, we know when order matters, it is permutation, right?
Yes, sir.
Okay, following that logic, we know this is this is what we will get, permutation is used. Now for this question, okay, this is the question. I think this is the last question.
So what are the subsequent questions, sir? Sub questions, sir.
Okay, this is the sub question. Okay,
Sir,
yes,
sir, can you do this question, sir?
I will do this. Yeah, I will definitely do this question, but I want others to do this first.
Sir, time will a lot be spent, please, sir.
Yeah, I will do this, but let's just give others a little while to solve this, because others also want to solve this. We'll do this.
Okay, sir.
I am solving every question. I'll solve this as well, but let's give others some time as well. Okay.
Okay, sir.
Okay, is everyone done?
Sir, I've made the T-tree diagram, but
Okay, you're not able to solve this.
yes, sir.
Should we discuss the solution to this question now?
Yes, sir.
So an engineer made a software that to filter spams, okay, before they reach the probability of emails that are spam. Okay, now let my S denote that the email is spam and NS denote it's not spam. Okay, this is there. So either it will be spam or it will not be a spam. What is the probability of email being spam? 30%. That translates to 0.3, right? And not spam will be 0.7. 1 minus 0.3. Okay. Now what
Yes,
is if the software made by engineer claims that it detects 99 of the spam and the probability for a non-spam email being detected as spam is 5%. Base this, what is the probability that an email is detected as spam? Okay, it is detected. Okay, it's detected as spam.
0.
So what is the
0.99.
probability? This what is this given to be? This is given to
0.99.
0.99. Okay, and what is the probability? This is given to 0.05. Okay, now how many ways can this email be detected as spam? It is spam detected. Okay, either it is spam and it is detected as spam, or it is not spam and it's still detected as spam, right? In these two
Excuse me,
cases,
sir, can you scroll up a little bit?
yeah, now it's
okay.
visible. Okay,
Yeah.
now either it will, either it will be spam and it will be detected as truly it will be detected as spam, or it cannot be spam and it can still be detected as spam, right? These are the ways in which my email will be detected as spam. Okay, so what is the probability is corresponding to each of these events? This is 0.3 into 0.99, or what can happen is 0.7 into 0.05. Solving this, I think we will get 0.33. Okay, just solve this now. Substitute the values. This is the answer comes out to be 0.33, and it's accepting answers in this range only. Any doubt in this question?
Yes, sir.
Okay, yeah. Yes.
Sir, not in this question, sir. Sir, what if this method to solve this by with arrows?
This is tree diagram. Have you seen ma'am's lectures? Have you gone through the lectures of this week 8?
Gone to the lecture for week 8.
Sir?
Week 8? Yeah.
Oh, sir, if his doubt has been cleared, sir, can I ask one question?
I don't think, right? Do you have still any doubts? This is called the tree diagram. It has been mentioned in the lectures as well. So basically, what is this? This is probability of spam. What I am writing here is probability of spam. What is this? This is probability of detected. Okay.
Given spam.
Given spam. Okay. This is what we are using is basically total probability theorem. Total probability theorem. Okay. Total probability theorem. Probability. I will in total probability, it will be probability of S into probability detected given S, or probability of not spam into probability of detected
given not spam.
Given not spam. This is our this what we call this as total probability theorem, right?
Right.
So this is just a pictorial representation how we see this tree diagram. Yes.
Sir, I am not confident in such type of questions. Sir, can you discuss some more?
We have discussed many such questions. We had these problem solving sessions daily. We have been discussing, I think, more than any other question, we have been discussing such questions. There are a few people in this meet that have been regular to those questions, like
in PYQ, sir.
No, we have solved these questions. Bayes theorem and this total probability. We have solved a lot of questions in this topic.
Sir?
Yes.
Sir, there is one activity question. So
Okay.
I posted it in discuss forum.
Discussion. Okay, I will get back to you today only, tonight in some time after this session. Okay.
Okay, sir.
So somebody was asking, can we discuss such more questions? You can. We had this revision session. It was I think yesterday only we had this revision session. You can get the link on YouTube. You can watch it there. We also had solved with us for week 8. We had an open session for week 8. We had these sessions. You go through all these sessions. We have solved a lot of questions from this topic. Okay.
Okay, sir.
These will be the YouTube links will be available to you. Now coming to the last question. If the email, okay, I will just give you a brief what happens. I'll just briefly tell you what is happening. Like you might be confused where I am going to use total probability and when I am going to use Bayes rule. Okay, is that so?
Yes, sir. Yes, sir.
Okay. See what happens is in this case. Now just let me remove this one. You understood this diagram that I made?
Yes, sir.
Okay. Now, what has been asked? I have been asked this end result, right? Okay. Okay. First, what we'll do one thing. We'll solve the next question because next question, what is it? Okay. First we'll solve next question first. Then we will see because these two questions are based on the same question. These sub questions are based on the sub question. And in this, we are using total probability. Total probability. In this, we are using Bayes rule. Okay. First, we'll solve these two questions. Then I will show you the distinction, how to differentiate between Bayes rule and total probability. Okay. Is that fine?
Okay, sir.
So everyone saw this.
So done, sir.
Okay, good. Let's wait for others as well.
Excuse me, sir. Sir,
Yes.
I have to leave now. I will see the remaining in YouTube.
Yes, sure, definitely.
Yeah, thank you.
Yeah.
Sir, is this question papers available as a link?
I don't think it is available as a link. I can. This is, you can just watch this session and you'll.
No, sir. Some other term question papers.
There are a lot. There have been a lot of quiz 2 exams, so there will be a lot of question papers.
Yeah, where can we find that link, sir?
I don't think the links are provided officially.
We can find it in Open Notes. It's a website made by students.
Yeah, that's what I told. Officially, you will not be able to get those. There might be some other open source people have like uploaded.
You can visit Open Notes. Then you will find there.
Just you can post this link in the chat box.
Okay. But I posted one.
Here you will be able to find these.
Okay, sir. Thank you.
Everyone is done with this question?
Yes, sir.
Okay. Okay, just solve it. Take the time.
Yes, sir.
Everyone is done? Anyone still solving? Just let me know. I'll wait for some more time. Okay.
Done.
Now let's discuss this. Now, in the same thing, I will explain. Somebody has doubt in Bayes theorem, right? Bayes rule. I will explain Bayes rule from here. I'll try to explain it as simply as possible. Okay, are you there? Somebody had doubt in Bayes rule.
Yes, sir.
What is my probability? The basic definition of probability of event A. Favorable cases by total cases.
Yes, sir.
Right? Favorable by total. So when we are dealing with these Bayes rule or Bayes theorem, we seem to sometimes overlook this formula. We seem to have lost track of this one. Bayes theorem is nothing but Bayes theorem is only this. Now I will explain you how Bayes theorem is this favorable cases by total cases. What is if the email is detected as spam? Now I have been given this has happened. Okay, this has happened. It is detected as spam. What is the probability that it is in fact a non-spam email? This is this, right? Now, what are my total cases? It will be detected as spam. That is my total cases. So what is the probability of total cases? Either it will be as spam and it will be detected, right? Or what can happen is it is a non-spam and it's still detected as spam, right?
Yes.
These are my total cases of an email being detected as a spam, right? Total cases. What is my favorable case in this question? It is a non-spam email.
It is
what is the
0.7 multiplied by 0.05.
Okay, this is in there. What is my probability? Favorable cases divided by total cases. What is my favorable case? 0.7 into 0.05. What are my total cases? This one. 0.3 into 0.99 plus 0.7 into 0.05. You solve this, you will get your solution. This is Bayes rule. This is nothing, just total favorable cases divided by total cases.
Okay. So,
yeah, is this clear now? Now, when to use Bayes theorem and when to use total probability? This is the main doubt. The main point of conflict is this. In this case, I had been given the end result has occurred, right? It was detected. So I will use Bayes theorem. When I know the end result has occurred, I am going to use Bayes rule. In this question, first question, where was the first question? It is detected as spam. I had just been asked about this. I was not given, this is the final result. I was not given, okay, this has happened, right? I was just asked the probability about this. So I will use total probability. But in this case, you can see email is detected as spam. The end case, it has occurred. This is occurred. This is given to me. So I will use Bayes rule.
Okay, sir.
Is this clear now when we use Bayes rule and when we use total probability?
Yes, sir.
So whenever we will get these questions, we will get both questions in one question.
No, this is not necessary. It can be or it cannot be. In this question, it is there, but it's not necessary that it will be there.
So then how we will understand, sir, that it is
okay. Suppose you were given only this one. So it's you have been asked only about the end result, right? Detected. Is it detected or not? So total probability. Suppose now you were given this one question. Email is detected as spam. So you know at the end I am getting a detected email as spam, right? You know the end result is spam. So Bayes theorem.
Okay, sir.
Okay.
I think I need to practice more, sir.
You need to practice a lot. Basically, like I just showed you, Bayes theorem is nothing but favorable cases by total cases, right?
Yes, sir.
This is there. You saw, like, keep this in mind. Every question will be easy for you. I have solved, like I think many people had the same doubt and we've taken this doubt previously as well. And I think there are a lot of people who are now cleared with this. I think so. So any doubts in this question?
No, sir.
Okay. There was one question that was left. I just overlooked it. There was one question. This is the question. This is the question.
So, sir, this is about rolling dice.
This is we have three events. This is the sorry. This is the main question is here. If you can see this, this is the main question here. I will just highlight this. Can you see this? Everyone is done with this question? Hello? Yeah, am I audible?
Yeah. Yes, sir.
Okay, done?
Yeah, sir. What is the question?
This is the question, the one that is highlighted in this highlighter pink.
Sir, that is not visible.
Okay, this is here.
Yeah, now it is visible, sir.
Okay.
These events.
Done, sir.
Okay. Now let's see the solution. Is everyone done with this? Everyone done?
Yes, sir.
Okay. So when we roll 3 die, when a fair die is rolled it thrice. Okay. When a fair die is rolled thrice or 3 dice are rolled simultaneously, this is basically one or the same events. So how many outcomes I will have? 6 raised power 3, right?
Yes,
or 3, that will be 216, right?
Yes, sir.
Just a moment, there is some issue here. So this will be 216. When I have got a 216 outcome, I know my sum is always either odd or always either even, right? So half of this will be odd,
Yes, sir.
half of this will be odd, half of this will be even, right?
Yes, sir.
So obviously my outcome is greater than 60, right? It will be 216 over 2. That is 108 outcomes in which sum is even. Okay.
Yes, sir.
So this is, it has more than 60 outcomes. Then total number of ways in which 6 beads can be arranged to form a necklace. So 6 beads. This will be n minus 1 factorial divided by 2. Right. Now this will be divided by 2. Right.
So it is not exceeding.
Yes, sir.
So what
It
is my
equal
n?
to
6 minus 1 factorial divided by 2. That will be equal to 5 factorial by 2. That is 60. Is 60 greater than 60? No.
Okay.
So B is not my correct answer. Okay. Any doubt in this one?
So I have doubt in C.
Sorry?
In option C.
You're not audible.
Sir, I have doubt in option C.
We'll discuss option C as well. Okay. What is your doubt in option C now? What is your doubt?
Sir, I'm not able to find a number of ways.
Okay, number of ways. How many 2 post box I have, right? This is post box 1, post box 2. P1. How many letters I have? 6 letters. 1, 2, 3, 4, 5, 6. What I can do, I can choose 5 letters from this 6C5, right? And I post it in this one. And 1 will go here, right? 5 here or 6, 1 here. Is this one case?
Yeah, yes, sir.
Or what I can do, I can choose 4 from these 6 and the remaining 2 will go here, right?
Right, sir.
Or what I can do is I can choose 3 from 3 here and 3 here, right?
Right, sir.
Or it will be 2 here and 4 here, or the final case will be 1 here and 5 here, right? Now how do we translate this? We will choose 5 letters from these 6 and these will go to P1 and 1 letter will go to this P2. Okay. For the second, it will be 6C4. 4 letters we are choosing and we will put them into P1. Okay. And we are left with 2 letters, right? So 2 letters will go there. For the third, it will be 6C3 and into 3. Right? They will go 3 letters we are choosing. They will go here. 3 letters we are left with. They will go there. And for the fourth, it will be 6C4. 6C4. We will 6C2 into 4. And the fifth, it will be 6C1 into 5. This is clearly greater than 60, right? Because if we look at we will add all these. We will add all these, right?
Yes.
We will add all these, but we can clearly see
Sir, why we are multiplying with
3
1, 2, 3, 4,
and multiplication rule.
Sir, we should multiply 6.
63, 62, 64, right, sir? Instead of 2, 3, 4, 5.
Yes, sir.
No, not 62. Okay. You are saying I should do this 64 into 62, right?
Yes, sir.
No.
Yes,
this is not what I should do. Why? If I am choosing,
4 into 250
I have already explained. This question has already been taken, I think. In previous session, there was some similar question. I am choosing 4 letters, right?
Yes, sir.
I am from these 6, I am choosing 4. Am I choosing these 2 or are these 2 left with me?
Okay, sir, understood. Sir, understood.
Right? Okay.
Yes, sir. Yes. My bad.
What, sir?
Oh, sorry.
I didn't get it.
Okay. I am choosing these 4 letters from 6 letters, right?
From 6. Yes, sir.
Am I choosing these 2 or am I just left with these 2?
I'm left with.
I'm not choosing these 2. Now I'm just choosing. Suppose these are my 6 letters. 1, 2, 3, 4, 5, 6. Suppose I chose these 4. 1, 2, 3, 4. Did I choose these 2? No, they are just left with me. That is why it's not 62. I'm not choosing these 2. I'm just choosing these 4, and these 2 are left with me. That because of that it's not 62.
Sir,
okay?
Then there is only one way, sir.
No,
then there is only one way by which you can post it in the second box. Then why we are multiplying with 2?
There are 2, like why?
If we have chosen
two ways will not.
Sir,
2
if
letters will.
we have
2
chosen
letters will.
4.
2 letters will have the option to go in the
2
second
letters
post
can
box.
be posted in second box in only one way.
But the thing is, 2 letters can be posted in there in 1 factorial way, right? Just a moment. Just a moment. What I am getting is 64. I am getting this arranged.
Sir, we have chosen.
Okay. We are not arranging. We are not arranging them. Just a moment. Just a moment. Just a moment.
Also, we will also choose them.
Just a moment. Yes. Okay. That is clear. I was arranging them. Sorry. So this will be this. Yeah. If I'm choosing this, these 2 will go there. We will get these 2 or 4 factorial if we are arranging them.
Hello.
This is just. Am I audible?
Hello.
Yes, sir.
Yeah, I am. Okay.
Yes,
Sir, will there any session tomorrow?
There tomorrow will be mock discussion.
Any doubt session, sir?
Doubt session? No. Doubt session is not there now.
Thank you, sir.
Oh, okay. So just a moment. So what I was doing is I was arranging them. That's why I made a mistake there. Yes, I made a mistake there. So this will be basically only this much, right?
Okay, so we need not to multiply or add anything else.
We will multiply if we have arranging them in 2 factorial ways. Then we will multiply them. But right now we are choosing 65. This will go into post box 1. Post box 2, of course, one way will be to put that 1 letter, and there will be, if we have 2 letters, they can only be put in there in 1 way, right?
Yes, sir.
So whatever this comes, this will be 6, this will be 15, this will be 20, this will be 15, this will be 6, 20, 50, 56, 62. So I have more than 60 outcomes again, right?
Yes, sir. So is he a
Sir?
Yes.
Sir, regarding the first one, option A.
Option A.
Odd and even. Sir, I approached it in a different way, and I got the different answer. So can I say?
Okay, just tell me that.
Okay, in order to the sum be even, 2 of the number has to be odd and 1 is even, right?
Or all 3 have to be even.
Okay.
And
Yes,
that is
yes.
what.
Okay, but
okay.
Yes, I missed that case.
All 3 can be. Yeah.
Sir, why we divide by 2 in the second option and minus 1?
Because in this it is that case where we had this clockwise and anti-clockwise same. Suppose these are your 6 beats, 1, 2, 3, 4, 5, 6. Suppose if you rotate this clockwise, this will still look the same, right?
Okay.
You take one have you seen those necklaces in which we have these beads, right? If you see it clockwise or anti-clockwise, if you rotate them, it is always the same. It's one or the same thing, right?
Yes, rotation free. If we watch at any position, the necklace looks the same.
The necklace is looking the same. Yeah, if you are rotating it like this is looking same. Even if you are rotating it like this is looking same. There is no difference. We cannot see any difference. Because of that, we are multiplied by 2.
Sir, but here it is not written that some numbers of beads are same.
See, these beads, when we have 6 beads, in this case, it is 6 beads are identical. When we mean beads, these beads are same beads. When they are different, it will be mentioned 6 different beads. Okay.
Sir,
like
then how
in that case,
one way is different from other way?
I am saying, see, if you have been given explicitly, we have 6 different beads. When you buy a necklace, like I told you, don't assume otherwise until stated. When you buy a necklace, suppose you bought a necklace, are the beads always different? No, you buy a necklace in which the beads are same, right?
Sir, then how one way is different from another way?
Means
all ways arrangement is same for all beads, no?
No, this is okay. In that sense, you're saying no. Suppose we have bead 1, bead 2 in clockwise and anti-clockwise. When we arrange them, that will be only one arrangement. I'm sorry to say that. My apologies. I'm saying if we have clockwise and anti-clockwise are coming to be same, I am getting bead 1. If I'm getting bead 1 here, then if someone is here, he's seeing bead 1 here, and to his right he's seeing bead 1. To his one side he's seeing bead 1, and to his another side he's seeing bead 2. So if these are coming to be same, if it is happening so that he's coming again B1 and B2, for this person, is this changing? No, this is just, he's just experiencing the same people there, right? When we do so, what this is a circular permutation where this repetition is no, sorry, circular permutation when with this clockwise and anti-clockwise are same, so we are just dividing by 2. We
sir, how it is same? That is not digested.
Just a moment, I'll just have some water first. Just a moment.
Yeah, I got it, sir.
Is it yeah, you got it?
Yes, sir.
Okay. Okay, any other doubts? Okay, regarding that one question we had, we have left with that this question, right? We are still to discuss this question. Okay, I think session we have a session tomorrow as well, right? So this question will be taken.
Sir, yeah, I want to ask one question.
Okay.
How many numbers can be formed using the digit 0, 1, 3, 5, 7, 9 without repetition such that the number formed is greater than 20,000?
Okay, I think I have solved this question on Discourse as well. Do you have access to Discourse?
No, sir.
Sorry, discussion forum. I'm sorry, I'm saying discussion forum.
No, sir. I will show what my screen shows is it shows that someone needs your.
No, that is Discourse. I am saying discussion forum.
No, sir. No.
Yeah, you will be there since you are. You just go to discussion forum. Search it on Google. Discussion forum. You will get there. There you will be added in this statistics. Just
sir, just 1 minute. I'm just showing my dashboard. What is my dashboard? What?
No, it's not on dashboard. It's not on dashboard. Is it on dashboard?
No, sir.
Sir, I don't know how to access it.
Sir, we have access to Discourse forum. And what is
can anybody
have you already qualified? Did you qualify in the previous term?
Yes, sir.
Yes, sir.
So those who have qualified in the previous term, they will have discourse, and those who qualified in this term, they will have discussion forum.
Sir, sir, when I log into Discourse,
Just a
it
moment.
says
I'm posting the link. I'll just post the link here in the chat box. Just a moment. Okay. Just a moment. Okay. Can you see this? I have posted it in the chat box. I'm using a different ID, but I have posted it.
So it is saying you do not have access to this page.
Just try using the email ID. Just change the email ID to the email ID that you have registered with. Okay.
The group name is statistics.
Yeah, this is the group for statistics. Yes. Now is it? Are you able to see this?
Sorry, actually I'm passed out. So that's
Sorry. Can you be clear? It's not audible. You're not audible.
actually I'm passed out. So I'm in Discourse, not in.
You can. So if you have discourse, you just post your question in discourse.
Sir, sir, it's showing content unavailable.
Yes, sir. It is not opening.
Okay, what you can do, you have doubt regarding to one question. Just
sir, please give me a little bit idea how to approach this question.
Okay, suppose okay, is my screen visible? It's still visible. Yes. Suppose you have been given a suppose 1 and 2, 3, 4. You have to you have to make a number greater than 200. Okay.
Yeah, the means number always start with a 2.
Not always starts with 2.
No, at least one first of start with 2, then with 3, then with 5, then with 7, then with 9.
Same. Exactly.
All the numbers we have to add separately.
Yeah, either it will start with 2, or this will start with 3, or this will start with 4, right?
Yes, sir, but the answer is not correct. It's
okay. Just send me the you don't have this discussion forum or neither you have this discourse, right?
Yes, sir. It's showing content is unavailable.
Just a moment.
From where you got that question? Activity assignment?
No, it's not activity. It's outside question. I don't even remember. Just a moment. I don't remember. Mail ID. I'm just checking this.
Sir, how to get access the discourse forum?
You will be automatically added there.
Sir, so then why I have not been added till now?
This will take some time. This takes. You had your qualifier in like this term. You had your qualifier, right?
No, sir. Just I have to. I'm going to give second quiz to.
No.
But tomorrow.
I know quiz 2 is day after tomorrow, but you qualified in this term, right? You had your qualifier on in previous month, right?
January term, yeah.
Yeah. So it will take some time. Okay, since you're not able to access this, I have mentioned my email ID. Just send me the question over there. I'll solve it. Okay.
Okay, sir.
Okay, regarding the one question that was left, there was one question that was left. This question.
Yes, sir.
Okay, I think this question will be taken. Will be taking this question tomorrow in the mock along with the mock. Okay.
Yes, sir.
So when will be the session held?
You will get a link for that. It will be updated in the calendar. Okay.
Okay, sir. Thank you, sir.
Okay. Yeah. So the session.
Sir, last time one thing to I want to ask, sir, how to get good confidence in this
Bayes theorem
this
and total probability, yeah.
Bayes theorem and total for probability and whole syllabus of week 1 to 8.
No, week 1 to 8.
Week 5
Okay,
to 8.
so week 5 to 8. Basically, I think most of the doubts where people feel a little lack of confidence is week 8 when this Bayes theorem and total probability comes into scene, right? So
Yes, sir.
we have been like for 2 weeks, I think more than a one week we have been just solving questions of Bayes theorem and this total probability. Can you see those links? We have this problem solving session twice a day, right?
Okay.
Similar,
Yes, sir.
the session that we are having right now, we have similar. Have you attended those solve with the instructor sessions that are from?
Yes, sometimes, sir, I have attended the session, but sometimes I have
Not really. So what happens is that those sessions are once or twice in the week, right? But there are sessions from 11 a.m. to 12 a.m. and 3 p.m. to 4 p.m. every day. In those sessions, in the morning one, we are always solving such questions, and we have solved a lot of questions regarding this Bayes theorem and total probability. Now, since those recordings we don't record those sessions, what I suggest you to do right now is to solve as many questions as possible. Even if you want to go, there is you will find a week 8 solve with us. Week 8 solve with us on YouTube. Okay, in that session we have explicitly defined like solved such questions, total probability and Bayes theorem. We have discussed how to differentiate between total probability and Bayes theorem. Okay.
Oh, one more thing, sir, I would like to add that peer deck slides are not updated. Only week 1 and week 2 slides are updated.
Okay. I don't think paired X slides are always
sir.
uploaded.
No, after week 2 the slides are not being updated.
Okay, I don't know the reason why they have not been uploaded. I don't think they're going to upload those. I don't think so.
Sir,
You can
last
just yes.
सर किसका वेटेज सबसे ज्यादा होगा कि वीक 8 से लेकर वीक 5 से लेकर वीक 8 का ज्यादा वेटेज होगा
For this quiz 2, more weightage will be from week 5 to week 8.
सर मैंने मॉक लगा लिया है ग्रेड असाइनमेंट कर दिया एक्टिविटी असाइनमेंट सारी
Sorry, your voice is like not clear. It's not clear.
सर मैंने मॉक लगा लिया है ग्रेड असाइनमेंट कर
Sir,
लिया
we can expect like more than 80% question from week 5 to 8.
I don't know exactly the weightage of like week 5 to week 8, but most of weightage will be from week 5 to week 8. More weightage will be from week 5 to week 8, right? In fact, we just saw we had just 2 questions from week 1 to week 4. It may not be
yes, sir,
okay.
yes.
Sometimes it might be 3, sometimes it might be 1, but more weightage will be week 5 to week 8.
Okay, sir.
There was someone else, they were saying something.
हाँ सर मैं यही बोल रहा था कि सर मैंने ग्रेड असाइनमेंट एक्टिविटी असाइनमेंट और मॉक लगा के रखा है सारा तो सर ये सफिशिएंट है कि नहीं मतलब कि
graded assignment mock as long as your concepts are clear, it's more than just sufficient. As long as your concepts are clear, you are able to solve everything nicely. You are like these sessions, if you have solved everything, what I would suggest you to do is there are revision sessions that were yesterday and day before.
Sir, I think some critical thinking are required for some questions. Not
Actually the aim of
methods,
these chapters, this aim of these chapters is to develop that critical thinking. The PNC is a very important chapter in this course of statistics because it helps you to develop that critical thinking that you're talking about.
And lots of practice are required, sir.
Yeah, lot of practice. If you want to be good in this course, you have to do like a lot of practice in these weeks. Week 5 with permutation and combination, do as much practice as you can, because you are able to see that even in probability we are introducing these PNCs, right?
Yes, sir. And even I have concept clears, there is silly mistakes that's happening.
Like for that you just need to practice more.
Yes,
and
sir.
Just go through. Once you're done with the solution, go through with the solution again and recheck it.
सर अभी स्टैट्स 2 भी आ रहा है तो उसमें भी सर ज्यादा critical thinking.
Exactly, critical thinking is required. Critical thinking will be required, and this, if the better you are at stats 1, the better you will be at stats 2. Okay.
Yes, sir. Thank you, sir.
Stats 2 just builds from stats 1. Try to be like, do your stats 1 very nicely. It will help you a lot in stats 2.
Sorry, this 5 to 8 weeks that I can say like it's the foundation of inferential statistics, right?
It is yes, it is the foundation. It is the foundation. We are introducing these probabilities, conditional probabilities, Bayes theorem, and after this there will be random variable in week 9 is coming. So this is the foundation of whatever we are going to study in statistics. Whatever we are going to do further, this is the foundation for all that.
Okay, thank you, sir.
Thank you, sir.
Thank you, sir.
So you will only taking mock
No,
tomorrow?
no. Instructor will be taking that.
Oh, instructor.
My instructor will be taking that. So that will be tomorrow.
Sir, are you doing teaching assistant, sir, in IIT
Yeah,
Madras?
teaching assistant. Yes.
So you are in second, third, like in diploma.
Oh, okay. No, not right now. But we can discuss that sometime else, since this is a live stream.
Okay, sir. No problem.
Okay.
Thank you, sir.
We can discuss that. You can come to those problem-solving solutions.
Good night,
we can do that. Okay. Goodbye, everyone.
Good night, sir.
Goodbye.
Goodbye.
Good night. Thank you, sir. Thank you very much.
Thank you, sir.